And then we've got today's notes. We'll hit the lights so that we can see this better. The least squares regression line. So it's the least squares regression line. Not as scary as it sounds. We are going to have a stop box. I haven't done that yet. You can get that stop box. All right. So the least squares regression line is also known as linear regression. So linear regression is used to find the equation of a line which best fits the data, since doing it by hand will yield different results for each person. So linear regression is this technique, and actually there's more than one method, but these techniques that we can do to find a line that kind of takes out that room for error between people all doing it by hand. Like we talked about yesterday, when you draw the line, you might have it tilted a little bit different. That would change the slope, and the y-intercept would change that equation. So you might have slightly different lines. Now, the most common method is called least squares. Now, I'm explaining it here in words, but we are also going to look at what that looks like in a diagram. So if these words in the second part aren't really making sense to you, I think the diagram will help that out. So with the least squares, that is that the sum of the squares of the distances from the points to the line should be small. So the line with the smallest sum is called the least squares regression line. It has the smallest sum, so that's where the least comes into play. And it's the sum of the squares, so that's why it's least squares regression line. So we have all these points on our scatter diagram. We want the distance from the points to the line, that value squared and all added up, to be as small as possible. Okay, are we ready for the picture? Not yet. The picture that we're going to look at is directly out of your textbook as well, so I don't think you need to necessarily draw it, but it just is a visual representation of what this is talking about here with the least squares regression line. So here's that picture. We have our line. We have 4 points that are, our data. There's a visual representation of that distance between the point and the line. So there's 4 different lines. So D1, D2, D3, D4 for the 4 different distances. So if we square those values and add all those values up, that line we want that to equal the smallest value in order to make a line. Is anyone else kind of like, what's going on? Wow. Lucky for us, we're going to use technology to find that regression line. So you don't have to measure and get distances and do squaring. We are not going to do that by hand at all. So It's the expectation that you absolutely use technology. You should not be doing it completely by hand for regression lines. So before you guys start scrambling to write this all down, the first 5 steps are exactly the same as the steps that we are in 21B to find R. So if you know how to find R from 21B, it's the exact same steps. This is for the TI-30XS yellow calculators. So, you select data, put in your information into the L1 and L2 columns. You want to quit out of there so you don't accidentally delete something. You got to select, I kind of did miss a step in here though, but some people are getting confused, but to select 2 var stats, you have to hit stat that's right above data. So go in there, make sure your L1 and L2 are highlighted, and then remember we had to scroll way down to find R on Monday. A and B are right before R. So if you want to write something down, I would write this part down so that you know that A is the gradient and B is the y-intercept. So when you write your line, it's like y equals ax plus b. So when you just plug it in, go there, scroll all the way down, and then you got your line. Today is mostly going to be making your scatter diagrams, figuring out your line, and then tomorrow we're going to expand on this to do some estimations. So I know I touched on it briefly yesterday about how we can plug in a value and we can figure out an estimate of what's going on. So that will also be happening tomorrow. That part of it. Today is mainly can you find the line. I will put the instructions up for the TI-84 as well. I see you still got some people jotting down the instructions here. So here's the stat box. This is a self-reflection here. What's holding you back from completing this assignment today? The clocks, I feel like they're only an hour off. The minute hand's about in the right spot. So instead of being 10:35, it's 9:35. So we have over a half hour, right? Just barely over a half hour. What's stopping you from finishing this assignment today? What? Doing the other 3? Okay. All right. Good plan. Anything else? Okay, so just a little bit of self-reflection about what, how we can use our time, but that's a great idea to get those other ones done first. That's a good one. My freshmen have a lot more excuses than you guys do when I ask them this question. They're tired or they're too hot. They're too hot or too cold lately. That's why they can't do their work. So the assignment is 1, 2, and 3. Hang on, it's not really going anywhere because these are the TI-84 directions. They are exactly the same as 21B. The only thing is if you've already done this step on your calculator, you won't have to do it again. So if you already did this step on your calculator for 21B, you will not have to repeat that. And it is an option for, and now you know what LINREG stands for, linear regression. So that's where R is, that's where A and B are also. Yeah. So that's the TI-84 if that's the calculator that you prefer.